Welcome back, viewers. Today I want us to look at a question which integrates the three methods for finding the area and a curve. In question 14, you're told to complete the table below for the function y is equals to x squared minus 3x plus 6 for the range of values of x between -2 and +8 to max. So you have x runs between -2 and +8. Here this is -1. Sorry for that. And now our function is given by y is equals to x squared minus 3x plus 6. So when x is -2, put -2 squared here, get +4 plus 6 plus 6. So that is 10 plus 6. This value here becomes 16. When x is -1, you have -1 squared is +1 plus 3, that is 4, plus 6, this is 10. When x is 0, we have 0 minus 0 plus 6. This gives you 6. When x is 1, you have 1 minus 3 plus 6. So -2 plus 6, that gives you +4. When x is 2, you have 4. That is 2 squared gives you 4. 4 minus 6 plus 6. So that gives you 10 minus 6, which is 4. When x is 3, you have 9 minus 9, which is 0. 0 plus 6 gives you 6. When x is 4, you have 16 minus 12 plus 6. So 16 minus 12, that gives you 4. 4 plus 6 gives you 10. When x is 5, you have 25 minus 15, that is 10. 10 plus 6 gives you 16. When x is 6, you have 36 minus 18. 36 minus 18 gives you 18, plus 6, 24. When x is 7, 49 minus 21, that is 28 plus 6 gives you 34. When x is 8, that is 64 minus 24. 40 plus 6 gives you 46. Like that. Now told in part B, use the trapezium rule with strips to estimate the area bounded by the curve y is equals to x squared minus 3x plus 6. The line x is equals to -2 x is equals to 8 and the x-axis. We've already seen the trapezoidal rule, and using the trapezoidal rule we are going first of all to get the uniform heights of the trapezius. In this particular case, I'm going to use uniform heights of 1 unit each. Why? Because here we've not been told the number of strips to use. So I'm going to use as many strips as possible, because the the more the strips you have, the more accurate your working will be under trapezoidal rule. So the height of every strip will be at an interval of 1, and then I'm going to get the ends at -2 we have 16, and at 8 we have 46. So the value of the ends are 16 and 46. And then the middles are the other values. Now we have 10, 6, 4, 4, 6, 10, 16, 16, we have 24 and 34. Those are the middles. So we go to the formula. Area now will be given by half height multiplied by total sum of the ends plus 2 multiplied by the total sum of the middles, like that. So we'll have this as, this will be given by half times 1 times into brackets total sum of the ends, that is 16 plus 46, which gives you 62, plus 2 multiplied by the total sum of the middles. Add all these values, 10 plus 6 plus 4 plus 4 plus 6 plus 10 plus 16 plus 24 plus 34. Add those values, you're going to get 114. You can confirm that using your calculator. So we go ahead and simplify this. When you multiply this, you get 0.5 multiplied by 62 plus 228. 62 plus 228, that gives you 290. So when you simplify this, you get 0.5 times 290. This gives you value of 145. So that is our first part of the question. In the second part, you're told to, or in the second method, you're told to use the mid-ordinate rule with 5 strips to estimate the area bounded by the curve y is equals to x squared minus 3x plus 6. The line x is equals to 2, -2, and x is equals to 8 and the x-axis. Now for us to get the 5 mid-ordinates, we are going to get our rectangles to be at interval of 2 units each. 2 units each. Therefore, in this particular case, the mid-ordinate will be, the first one will be at -1, the second one will be at +1, the third one at +3, the fourth one at +5, and the last one at +7. So those rectangles will be having a base of 2 units each. So the area now in part C, using mid-ordinate, the area will be given by the common height multiplied by the sum of the mid-ordinates. And our height, we have seen that our height, common height, will be equivalent to 2 units. And what are these mid-ordinates we are talking about? The first mid-ordinate we are talking about is, so it will be 2 multiplied by 10, this one here, plus 4, plus 6, plus 16, plus 34. So the area will be equivalent to 2 multiplied by, when you add all these values, add all those values, so you're going to get a value of 50 plus 20. This is 50 plus 20, 70. So 2 times 70, which is equal to 140. 140. So that is the area using the mid-ordinate rule. Finally, you now want to find the area using integration. In the last part, you told to, or by integration, determine the actual area bounded by the curve y is equals to x squared minus 3x plus 6. The line x is equals to -2, x is equals to 8, and the x-axis. So first of all, what you need to do, we need to get the function in part D. We get the function and integrate it. Y is equals to x squared minus 3x plus 6. We integrate this function x squared minus 3x plus 6 with respect to x, so that we can get the definite integral. Now, here we are going to introduce, or when we integrate this, we are going to introduce the square brackets and have our integrated function as x cubed over 3 minus 3x squared over 2 plus 6x, and we have the value for the upper limit as 8 and the value for the lower limit as negative 2. And then now we go ahead and evaluate for this. Now with much practice, we are doing away with the constant of integration, which is c, because we know that after working out, c will cancel out in the process of our calculation. So after getting our square brackets, we now go ahead and evaluate. We had x cubed over 3 minus 3x squared over 2 plus 6x, and the upper limit 8, the lower limit negative 2. So we go ahead and open the brackets. We're going to get this as, we start with 8 cubed is going to give us 512 over 3 minus 3x squared, that is 64 times 3, 192 over 2 plus 48. The whole of that minus negative 2 cubed gives us negative 8 over 3. 6 times, 3 times negative 2 squared. Negative 2 squared is positive 4. 3 times negative 3 times positive 4, that gives us negative 12 over 2. And then we have 6 multiplied by negative 2, that gives you negative 12, like that. So when you work out this using your calculator, you can work out all that. You're going to get a value of 122 and 2/3 minus, into brackets. When you work out this again, work out using your calculator, you're going to get a value of negative 20 and 2/3. So when you open the brackets, you're going to get an addition sign, and you'll get 122 and 2/3 plus 20 and 2/3, which gives you a value of 143 and 1/3. 143 and 1/3. So that is how you can answer such type of a question using the 3 methods. So the examiner might also ask you to find the exact area, and we already know that if given such a question, integration is the only method through which you can find the area of an irregular shape with an exact value. Thank you for watching.